And it's time for another fun math contest problem from 2016, AIME 2, question 3. Let x, y, and z be real numbers satisfying the system. Log base 2 of xyz minus 3 plus log base 5 of x equals 5. Log base 3 of xyz minus 3 plus log base 5 of y equals 4. And log base 4 of xyz minus 3 plus log base 5 of z equals 4. Find the value of the magnitude of, or absolute value of log base 5 of x plus log base 5 of y plus log base 5 of z. Okay, so this problem, I actually got most of the way through it, but then, like an idiot, I missed something. I thought I had checked it, but I didn't. I'll show you where that happened, but then it's actually not too bad. So what I'm doing first, to clean these up a little bit, I'm going to use both sides of this as a power of 2, which would leave me with x, y, z minus 3 plus log base 5 of x equals 32. I'm going to use both of these sides as a power of 3, which is going to cancel out this log base 3, so I get x, y, z minus 3 plus log base 5 of y equals 3 to the 4th, which is 81. And use both of these sides as a power of 40, or the log base 4, and I'll get x, y, z minus 3 plus log base 5 of z equals 4 to the 4th is going to give me 256. And I solved these for the log base 5 of x, y, and z. So that gave me log base 5 of x will equal 35 minus x, y, z. This one gave me log base 5 of y was going to be 84 minus x, y, z. And this one gave me log base 5 of z equals 259 minus x, y, z. And now I noticed I really want to get to this, and I did the following thing for this reason, even though it's not actually directly into there. I added straight down. And I know when I do log base 5 of x plus log base 5 of y plus log base 5 of z by the sum of logs rule, we get the log base 5 of x times y times z. And when I add these down, I should get 378. So I get 378 minus 3xyz. And I got to this point just fine when I was solving it. I thought, okay, what's going to make this work? Well, what if I made this equal to 125? And I said, okay, so log base 5 of 125 is 3, but 378 minus 125 isn't 3. I missed the fact that there's a minus 3 times this here. So it does happen to be that xyz must equal 125 in this equation because log base 5 of 125 is equal to 378 minus 375. And once I have that, now I can see the following. So if I substitute this in here, 125 for xyz, 35 minus 125 is negative 90. And when I substitute 125 in here, I get, let me make sure I'm doing this correctly, negative 41. Sorry, wrong color. Let me get the right color up here for you guys. Negative 41. And when I substitute 125 in for here, I will get, that's going to give me 125 plus 9 more, positive 134. And that's log base 5 of x, log base 5 of y, log base 5 of z. So finally, I can consider this the magnitude of log base 5 of x is going to be a positive 90. The magnitude of log base 5 of y is going to be a positive 41. And the magnitude of log base 5 of z is going to be a positive 134. When I add those together, I end up getting, let's see, 5, 4 plus 3, 7, plus 9, 6, carry the 1, 265. Any questions? Leave them in the comments down below.